Question 6. Propene reacts with concentrated sulfuric acid to form two isomers E and F. The structure of E is shown below. So do a name of the mechanism. So the mechanism electrophilic addition, we'll have a look at that in a minute. So the mechanism, I've done propene here. Prop, remember, has got 3 carbons. You can see the 3 carbons in the product here. And ene means that it's got a double bond. The double bond attacks the delta plus of this polar bond. You've got to remember the structure of sulfuric acid. It won't be given to you. You can possibly work it out from here, but that may not be given to you. You need to remember the structure of sulfuric acid. A sulfur has 2 double bonded oxygens and then 2 OHs. And one of these, remember, this has got hydrogen bonds here, so it's got a very polar bond here, and sulfuric acid will have hydrogen bonds between separate sulfuric acid molecules, because this is a very polar bond. Oxygen is very electronegative compared to hydrogen, so you've got quite large delta plus and delta minuses here. So we've got a polar bond here. The oxygen's electronegative, withdraws electrons along the bond towards itself. That's why it gets a delta minus charge. Now the electrons in the double bond of the propene are going to attack or bond with the delta plus here of the hydrogen, and then the hydrogen is going to bond to the propene. The electrons here, the hydrogen can't bond to the propene and also remain bonded to the oxygen, so the oxygen takes the electrons from the covalent bond and gets a minus charge, and there's the pair of electrons as a lone pair now on the oxygen. What actually happens here is that the hydrogen bonds to one of these 2 carbons. How can you remember which one it bonds to? Well, the hydrogen bonds to the carbon with the most number of carbons. So that's one way of remembering where it bonds in most cases. So usually what happens is the hydrogen will bond to the carbon that's got the most number of hydrogens. This carbon's got 1 hydrogen, this carbon's got 2, so it's going to bond onto this carbon that's got more hydrogens. This carbon's got 2 hydrogens, this one's only got 1, so it's going to bond onto here, and I've drawn the hydrogen bonded onto here. That's what's going to happen in most cases. That's called a major product, what happens in most cases. Now this carbon here in the middle hasn't got enough bonds. The carbon is bonded to this carbon here, that's 1 bond, and H is 2 bonds, and also this carbon here. It's only got 3 bonds, and it should have 4. If it's only got 3 bonds, it's short of a bond. In a bond are electrons, so it's short of electrons, it's short of a bond, so it gets a plus charge. So that's where the plus charge is. To balance out the minus charge, remember, we'll make a minus charge because electrons have been dumped onto the O, and that therefore will get a minus charge. Arrow coming this way onto the O means there's a minus charge. I've got to make a plus charge somewhere to balance that out, this minus that I've just made, and that's where it is. It's on that carbon, because that carbon has not got enough bonds. Now, the arrow doesn't come from the minus charge, it comes from a lone pair of electrons. Remember, this lone pair of electrons here is going to be used to form a covalent bond. So it's got to come from the lone pair of electrons, because there'll be a pair of electrons in this covalent bond here. So it comes from the pair of electrons that are being used to bond to this carbon. When it bonds, I've drawn the bond here, and I've got the sulfuric acid now bonded onto the middle carbon. The plus charge disappears. That goes because I've got an arrow coming onto the plus charge. So if an arrow comes onto a plus charge, it removes the plus charge, and if an arrow goes away from something with a minus charge, it removes the minus charge. So that's then the answer there, and that's the major product formed because this hydrogen goes onto the carbon with most hydrogens. We'll explain why that happens in the next part of the question. 6.2. Draw the structure of F. So F is the other isomer. The other isomer is what happens if this rule doesn't happen. In other words, the major product doesn't happen. In actual fact, the hydrogen goes onto the middle one here, the middle carbon, and the plus charge ends up at the end. Well, the simple difference is that this H and this sulfuric acid will be the other way round. So what that will do is the H is now bonded onto the middle carbon and the sulfuric acid has gone onto the end. This is the minor product. This is what's probably not going to happen. A small amount will be made, but it's probably not going to happen. The major product is going to be this one. So why is this one formed? Why does the hydrogen go onto the end, onto the carbon that's got most hydrogens already, and leave the plus charge in the middle, and the sulfuric acid joins onto the middle carbon, carbon number 2, instead of going onto carbon number 1? And the answer to that is here. Explain why more of isomer E, why you get this major product here rather than this minor product here is formed in the reaction. And the answer is that a stable secondary carbocation is formed. It's stable. it's due to the two methyl groups repelling electrons. So what actually happens is, if we go back here, this is a secondary carbocation. A carbocation is something where you've got a carbon with a plus charge, so it's a carbocation. Secondary means the carbon with the plus has got two other carbons bonded to it. If it only had one carbon bonded to it, it would be a primary carbocation. If it's got three carbons bonded to the C with the plus, it's a tertiary carbocation. In this case, the C plus, the carbocation, has got two other carbons either side bonded to it, so it's secondary carbocation and it's stable. If the hydrogen had bonded to the middle carbon, then the C plus would have been on the end carbon, would be on carbon number 1 on the end, on the right hand side, and that would be a primary carbocation, which wouldn't be as stable. And the reason that that happens, if you really want to make sure that you get all the marks, is that the two methyl groups either side of the carbocation, to the left and right, repel electrons and lower the size of the C plus, lower the size of the plus charge on the carbon. You don't need to mention that bit, but you might get, for the second mark, you might need to mention the two methyl groups repel electrons. These two methyl groups here, here, and here repel electrons. In actual fact, as I say, what happens is it lowers the size, the plus charge, and increases stability on the secondary carbocation. So if the hydrogen had gone onto the middle one and the plus had been on the right hand side, that would have been a primary carbocation, which would have been less stable. Just incidentally, the tertiary carbocation is even more stable because it's got three methyl groups surrounding the carbocation, C plus, all repelling electrons.